Chapter 8, Lesson 2, Function Rules. Our content target, students will understand that function rules can be written when given various inputs and outputs. Our content target, students will demonstrate their understanding by finding the function rule given a table of values. So arithmetic and geometric sequences. Determining if a sequence is arithmetic or geometric can help you find the pattern. When you know the pattern, you can continue the sequence to find missing terms. In an arithmetic sequence, it has a constant difference, add or subtract, between each term, where a geometric sequence has a constant ratio or multiplier between each term. So in other words, an arithmetic sequence adds or subtracts. A geometric sequence will multiply. So when I look at example number 1, describe the relationship between the terms in the arithmetic sequence 7, 14, 21, 28, then write the next 3 terms. Well, I know from 7 to 14, I have to add 7. I could also multiply by 2, but is 14 times 2 21? No, so I'm not multiplying by 2. So I have to see if my add 7 works. Is 14 plus 7 21? Yes, it is. Again, I got to check to make sure my sequence is correct. So from 21 to 28, do I add 7? 21 plus 7 is 28, so that is correct. So my rule is add 7. So now I have to write the next 3 terms. So starting at 28, what is 28 plus 7? That would be 35. 35 plus 7 is 42. 42 plus 7 would be 49. Number 2, again, describe the relationship between the terms in the geometric sequence 2, 4, 8, 16, and then write the next 3 terms. So again, my algebraic expression, I'm either adding or subtracting. Geometric means I have to multiply. So what can I multiply by 2 to get 4? Well, I know times 2, 2 times 2 is 4. Does that rule work for the next one? Is 4 times 2 8? Yes, that is true. So what is 8 times 2? 16? Yes, it is. So I know that my rule is multiply by 2. That's my rule. So now I have to write the next 3 terms. So starting at 16, what is 16 times 2? Is 32. 32 times 2 is 64. And 64 times 2 is 128. So there's the next 3 numbers in my sequence. So here's our got it problem. Let's look at these 2 and see if we can decide if it's algebraic or geometric. So I have 0 to 15. Well, I can add 15 to 0. 0 plus 15 is 15. Is there anything I can multiply by 0 to get 15? No, because anything times 0 is 0. So multiplying doesn't work. So my rule must be add 15. So let's check it out. Is 15 plus 15 30? Yes, it is. Is 30 plus 15 45? Yes, it is. So if I'm going to write the next 3 numbers in my sequence, I'm going to add 15 to both sides. So I have 45 plus 15 is 60. 60 plus 15 is 75. And 75 plus 15 is 90. So there's the next 3 numbers in my sequence. Let's look at letter B. I have 4.5 to 4. And from 4 to 3.5 and 3.5 to 3. Well, my numbers are getting smaller, so that means I have to be subtracting. So it looks like from 4.5 to 4, I'm subtracting 0.5. Let's see if that works up here. Is 4 minus 0.5 3.5? Yes, it is. Is 3.5 minus 0.5 3? Yes, it is. So again, I want to rewrite my sequence starting with 3 and taking away 0.5. So if I take away 50 cents from $3, I get $2.50. If I take away 50 cents from $2.50, I have $2. If I take 50 cents away from $2, I get $1.50. There's the three numbers, the next three numbers in my sequence. So to find a rule, a sequence can always be shown in a table. The table gives both the position of the term in the list and the value of the term. Position's always at the top, your value's at the bottom. You can write an algebraic expression to describe a sequence. The value of each term can be described as a function of its position in the sequence. In the table above, the position can be considered the input and the value of the term the output. So here's my input. So we want to use words and symbols to describe the value of each term as a function of its position. Then find the 10th term. So in this case, when I look at my position and value, I'm going from 1 to 3. So I know that I'm either adding 2 or I'm multiplying by 3. So I look at my next one, from 2 to 6. Is 2 plus 2 6? No. So I know adding 2 is not the right rule. Let's try and multiply by 3. Is 2 times 3 6? Yes. So let's try 3. Is 3 times 3 9? Yes. Is 4 times 3 12? Yes. So my rule is times 3. Now to find the 10th term. To find the 10th term, I would take 10 and multiply it by 3 to get 30. Now we have a variable here. The variable, just like as the number, represents some number. So how do I find the value of n? Well, I have to multiply n times 3 to get 3n. So when I look at the last two, we're going to use words and symbols to describe the value of each term as a function of its position. Then we're going to find the 8th term. So we want to find the 8th number in each one of these. So if I look at the first one, E, I go from 2 to 12. So from 2 to 12, I'm either adding 10 or I can multiply by 6. So let's try the next one. 3 plus 10 is 18. No. 3 plus 10 is 13. So this rule doesn't work. Does multiply by 6. 3 times 6, 18? Yes. 4 times 6, 24? Yes. 5 times 6, 30? Yes. So I know my rule is times 6. So to find the 8th term, if my position was 8, 8 times 6 would be 48. N would be 6n. Because I don't know whatever the position is, I simply have to multiply that by 6. Let's look at letter F. From 3 to 7. 3 to 7, I can add 4, or I can multiply by, well, 3 doesn't go into 7 equally, so I know I'm not multiplying. So let's try my rule. Is 4 plus 4 8? Yes. Is 5 plus 4 9? Yes. Is 6 plus 4 10? Yes. So I know my rule is add 4. So if I want to know the eighth number, 8 plus 4 would be 12. To find n, I would take whatever the position number is, n, and I would add 4.